Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper trending on X, published on December 11, 2025, about 3 days ago. It introduces a new motion-focused editing benchmark and a training method that boosts a base editor's overall score from 3.84 to 4.25 and raises its pairwise win rate from about 58% to 65% on challenging motion edits. The paper is titled MotionEdit, Benchmarking and Learning Motion-Centric Image Editing. And as we will see later, the combination of this dataset and training recipe could reshape how image editors handle realistic motion. Alright, Figure 1 lays out side-by-side case studies that compare several commercial editors against Motion NFT for motion-focused instructions. The grid shows 4 example prompts in rows and different models in columns, ending with the ground truth results. Red circles highlight where commercial models keep images pretty but miss the requested motion, such as the foot not really crushing the apple or the car not truly falling. The Motion NFT column matches the target poses and trajectories much better, so characters and objects actually move as the text describes. While Figure 2 contrasts old benchmarks with the new motion-focused dataset, the large left block shows 2 bottlenecks. Some datasets only change appearance, like color or texture, while others attempt motion edits but produce inconsistent or artifact-ridden targets, which the red circles highlight. The right block presents motion edit pairs, where the person or character clearly changes action, such as sipping coffee or turning to face another, while identity and scenes stay consistent. Alright, the previous figure contrasted dataset quality, and Figure 5 now spells out what kinds of motion these examples actually cover. The 6 columns illustrate pose changes, locomotion and distance shifts, object state changes like fireworks fading, and orientation or viewpoint tweaks where a character turns away. The last 2 columns show subject-object interactions, such as vacuuming confetti, and intersubject interactions like a dentist turning away from a patient to adjust the chair. Together, these categories define the motion edit space that the benchmark systematically evaluates. So while Figure 5 categorizes motion types, Figure 4 explains how those examples arise from raw videos. The left block shows long clips being chunked and converted into start and end frames that capture potential motion edits. The central block depicts a multimodal, large language model judge, which inspects each frame pair for stable setting, significant motion change, and clean subjects, then keeps or drops it. The right block illustrates a rewrite module that turns the judged motion summary into a short, imperative editing instruction that directly matches the visual change. Alright, the previous figure traced how frame pairs and instructions were created, and Figure 6 now quantifies how much motion those pairs actually contain. The bar chart compares average input to target motion differences across 6 editing datasets. Legacy sets like MagicBrush, AnyEdit, and OmniEdit sit near 0.03 to 0.07, which means only subtle changes. The motion edit bar jumps to about 0.19, showing roughly 3 to 6 times larger motion and confirming that this benchmark demands genuinely substantial transformations. So while Figure 6 quantified how much motion the dataset demands, Figure 7 shows how Motion NFT turns that motion into a training signal. The left panel draws a candidate edit from the flow matching model and pairs it with the ground truth frame. The middle block runs Unimatch to compute optical flow for both images. The right stack then breaks this flow into magnitude, direction, and movement regularization terms, combines them into a single motion NFT reward, and feeds that score back into training. So the previous figure unpacked how the motion reward is computed, and Table 1 now shows what that buys in practice on the motion edit benchmark. The upper block lists existing editors, where diffusion-based tools like AnyEdit and MagicBrush stay near an overall score of about 1 to 2 and have low motion alignment and win rates. The highlighted middle block shows FluxPoint1 context jumping from 3.84 overall and a 58% win rate to 4.25 overall and 65% once Motion NFT is applied. The lower highlighted block shows a similar boost for Q1 ImageEdit, which climbs from 4.65 to 4.72 overall and from about 73 to 74% win rate, confirming that the motion-aware fine-tuning reliably strengthens both quality and motion fidelity. MotionEdit delivers 2 big contributions: a realistic motion editing benchmark with much larger and cleaner action changes than prior sets, and Motion NFT, a lightweight training recipe that measurably boosts motion fidelity without hurting general editing. Together they push image editing closer to controllable animation. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.